our friend joining our session.
Sering cakep. Bluetooth sama.
Ngomongnya bahasa Filipina.
Satu mau disita ya wes ini. Wah, muantuk mau.
Kamu ada yang topik udah kasih kamu kan? Jadi
Tuh, sekarang balik. Naikin. Jadi kan pasti yang foto pada 5 menit terakhir deh. Tantangan.
Good afternoon, Pak Pandi.
Good afternoon, Dr. Azizul.
Thank you and welcome to our event.
Okay, thank you.
I'm really grateful for you joining our
Yes.
event today. I hope
Okay.
this event will go smoothly for today and another a couple days ahead. We are still waiting for other participants to join, so I hope all of you will be patient enough to wait. Probably in the next 2 or 5 minutes, we will start our session for today. Thank you. Yes. Good afternoon, and thank you for your patience waiting for the session to start. And ladies and gentlemen, it is a pleasure to welcome all of you to the International Joint Lecture Series in Biology and Biology Education 2025. My name is Azul Wicaksono, and I'm honored to be your MC for this lecture series today. We're glad that we have such a wonderful group of attendees and speakers as well joining us today. Thank you for being here, and we really grateful for your interest to our events. And this event is brought to you by the cooperation between Universitas Persatuan Guru Republik Indonesia Semarang and Don Mariano Marcos Memorial State University, Philippines. To start our event, let us begin by honoring the national anthem of Indonesia, followed by the national anthem of Philippines. Oh, I'm really sorry. There's some technical problem. Just, I hope you can wait a little bit for the video to be played. Okay, ladies and gentlemen, we really sorry for the inconvenience because of there's some technical error. We cannot play the national anthem for both country. So next, we move to the next agenda. For officially open our events, it is my great pleasure to invite Dr. Supandi, Dean of Faculty of Mathematics, Science, and Information Technology Education, to deliver the opening speech. So for Dr. Supandi, please welcome.
Okay, thank you so much, Dr. Cecil. Assalamualaikum warahmatullahi wabarakatuh. Honorable guests, distinguished speakers who have kindly joined us to share their valuable insights, esteemed lecturers, educators, researchers, and practitioners in the field of biology and biology education, and all the participants of this seminar, whom I hold in the highest regard. First and foremost, let us express our deepest gratitude to God Almighty for His abundant blessing, for allowing us to gather here today in the International Joint Lecture Series in Biology and Biology Education 2025 in good health and high spirits. The seminar is collaboration effort between Universitas Persatuan Guru Republik Indonesia Semarang, Indonesia, and Don Mariano Marcos Memorial State University, Philippines. This seminar serves as an invaluable platform for all us to exchange knowledge, broaden our perspective, and build meaningful scientific network in the field of biology and biology education. In this phase of global challenge such as climate change, biodiversity loss, and the post-pandemic maybe educational crisis, the role of biological scientific and effective teaching strategy has become even more critical in shaping a generation that is not only environmentally conscious, but also critical and solution-driven. Ladies and gentlemen, we hope that throughout this seminar, fresh idea and strategic collaboration will arise, helping to address the pressing challenge of our time, both in research and in the development of curricula and teaching methodologies for the digital age. In closing, ladies and gentlemen, we would like to express our sincere appreciation to all those involved, especially our esteemed speakers, participants, organizers, and partners whose support has been essential to the success of this event. May the seminar bring valuable insight and blessing to us all, and ignite the passion to continue contributing to the progress of biology sciences and education in Indonesia and Philippines. So enjoy the seminar, engage it in fruitful discussion, and may you find inspiration in every moment. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you, Dr. Supandi, for your insightful words. Now we have next opening speech, and it is my pleasure to invite Dr. Jesus Rafael, the Director for Internationalization, Linkage, and EEAP from Don Mariano Marcos Memorial State University. So please welcome Dr. Rafael.
All right, so thank you very much, Mr. Azizul. Good day, everyone. Good afternoon. We say magandang hapon in our language, Filipino or Tagalog. And it is such a pleasure to be here joining you again. Actually, this is my third time to do the opening speech for the lecture series. We're done with the mathematics and the education program. Now we're doing the biology program for the first time. And on behalf of the Don Mariano Marcos Memorial State University here in the Philippines, I'd like to send warm regards and big thank you to our dear friends from Universitas PGRI Semarang. And every time we do this, every time we do something together with UPRIS, this actually reminds me of how strong and special our partnership has become. Can you believe that this started back in 2016, no? With just a simple friendship between two faculty members. From that small beginning, we have now built something meaningful and special between our two institutions. We have done international credit transfer programs, the C teacher program under the CIMEO, exchange program, the guest lecture series, and now the continuing lecture series in various disciplines. And in fact, if I'm not mistaken, this is already the fifth discipline that we're doing this lecture series. And there are still other programs and disciplines coming up this quarter. So that says a lot about the trust, the teamwork, and the friendship between DIMSU and your universities. And of course, I'm very much thankful to be seeing you all online, and I really hope the time will come when we'll be meeting face to face. No, I want to be able to sit down with you, talk more, learn from each other, and really experience each other's culture in face to face. Actually, we're just waiting for your invitation. Our DIMSO lecturers, Ma'am Anja and Sir Rodley, are here. They are just waiting for your invitations. I hope that you could also invite our faculty members to be there in UPRIS doing this lecture face to face. And of course, you're always welcome here. Just like how we have welcomed your students, your C teacher students, and of course, the ever-present Dr. Noor, no? Your director for international affairs. And so Greece has been part of our community, actually a family already, and we're proud of that. And now that it's summer here in the Philippines, we would also like to invite you maybe in May or June to do the lecture series on site. So this kind of partnership shows how powerful it is when minds meet, when people connect beyond borders, and when we converse in so many different things or ideas. So we may be in different countries. You are in Indonesia, we are here in the Philippines, but our goals in education, science, and more projects and more memories together with UPRIS, whether online or hopefully soon in person. We're happy to keep working with all of you. Terima kasih. Thank you very much. Maraming salamat. Mabuhay po tayong lahat.
Okay, thank you, Dr. Rafael, for your thoughtful remarks. And of course, we also hope that for the next future, for the near future, there will be more cooperation between two parties for either online or offline events in academic or in non-academic as well. We hope so. Okay, now we officially open our event today. And for main event, we have two sessions for the lecture series. The first series, there will be two incredible speakers, Mrs. Anja and Mr. Rotley. And the second session, we have a speaker from Universitas Persatuan Guru Republik Indonesia Semarang. We have Mrs. Fanny Rosayanti and Mr. Prasetyo. For the first lecture series, for the first session, it will be guided by our colleague, Mr. Simon. So please, Mr. Simon, now I hand over the first session to you as the first moderator. Mr. Simon, the floor is yours. Okay, for ladies and gentlemen, for the first session, it should be moderated by Mr. Simon from Don Mariano Marcos Memorial State University, but we still waiting for him to take over the session. So I hope you will be patient enough, and we really sorry for the inconvenience. And of course, we have two incredible speakers and with the distinguished topic. So I hope everything that we got today will be benefit for us in our academic life, especially. Yeah. Okay, okay. For the first session for today's event, for the first session, we have Mrs. Anya and Mr. Rotley. So I will be the moderator for the first session as well. And for today's lecture series, we have its a speaker 20 minutes to present their topic. After first speaker and then follow the second speaker, and the third we have a Q&A session, so all of them together. So if all of the participants, all of you want to ask a question either for Mr. Rotley or Mrs. Anja, please raise your hand and turn on your microphone, and please introduce yourself and state to whom your question to be directed with. Okay, now we can start. And I would like to ask Mrs. Anja, please, the floor is yours, and please you can present your topic.
Hello, sir. Good
Yes, we
afternoon.
can hear you. Good afternoon.
Yes, may I share my presentation?
Okay, yes. I'm very happy to have you here. I hope you enjoy as well our events.
Or sir,
Yes.
thank you for sharing this opportunity.
Yes.
Is my video already visible?
Yes, yes, we can see your slide.
Mhm.
Okay, Miss Anja, probably you can put it in the slideshow.
Okay. Is it already visible, sir?
Yes, yes, yes. It
Okay,
looks
thank
great.
you very much. Good afternoon, everyone. So for this afternoon, I'll be giving a lecture on the topic entitled Cracking the Code of Biology, Overcoming Common Learning Challenges. So we all know that biology is a very interesting subject because it deals with nature and it allows us to have an in-depth understanding of living things, and it also explains life processes. However, just like in other disciplines, we also encounter a lot of challenges in dealing with this subject. In the research of Batul et al., they're able to come up with a model which presents the language issues in biology classroom. And the number one issue here is in terms of terminologies that are being used in biology. So we all know that biology has a lot of terminologies, very difficult terminologies. They're difficult to pronounce, difficult to spell, difficult to write, and they are unfamiliar to us because they are derived from Latin and Greek words. Another issue is in terms of lack of active reading. Many students just simply read science texts, but they fail to comprehend or understand what they are reading. Another issue is the limited connection and use of biological language in daily life. So we don't commonly use biology terms in our everyday conversations. Like, for example, instead of saying, or we don't say, I want to urinate, instead we say, I want to pee, or um, I'm respiring, instead we say, I'm breathing. So we don't commonly use biological terms in our everyday life. Another issue is the organization of textbook. So some textbooks fail to give further description and explanation of different concepts in biology. Another is in terms of lack of conceptual understanding. So many students tend to simply memorize terminologies. Yes, they can read, they can recognize terms, they can memorize them. However, they don't. When you ask them to define or to explain the concept, they actually fail to do it because they lack understanding. Another issue is scientific writing. So in scientific writing, there is a specific way or style of writing which is different from other styles of writing. So in order for an individual to be able to do a scientific writing, he or she must have knowledge or yes, knowledge about scientific terms and scientific concepts. Another problem or issue is about conceptual density. So biology entails a lot of information, a lot of terminologies, a lot of concepts that are difficult to grasp. Now the question is, how can we address these language issues in biology? So according to et al., to improve vocabulary learning, we must incorporate more opportunities for students to engage directly with the terms. So in other words, um, we have to engage our students to reading because the more that they read, the more that they become familiar with different terminologies, and the more that they gain deep understanding of scientific concepts. However, based on experience also as a teacher, whenever we give our students a reading material, um, let's say we give them an assignment to read it, for sure they will not read it. Or of course, we're not sure whether they really understand what they are reading. So therefore, as teachers, we have to think of a way on how to engage our students fully to reading, and we have to think of a strategy that would help them and increase their interest in reading. And so for this afternoon, I'll be presenting some classroom strategies that we can implement or use in our respective classes, in our biology classes to be specific, which may help in enhancing the reading comprehension of our students, and which may as well help to respond or address language issues in biology. Okay, so the first strategy is morphemic analysis. So if we talk of morphemes, these are actually the basic unit of language, which is or which have meanings. So this may be a suffix, a prefix, or a root word. And if we say morphemic analysis, we identify the smallest meaningful units in words. Like for example, we have here the word photosynthesis. So this is made up of morphemes such as a photo, which means light, and then we have the word scene, which means with or together, and thesis, which means setting or putting or placing. So if we put these terms together, we can now define photosynthesis as putting together with light. So we all know that photosynthesis is a process. This is actually an example of an anabolic activity, which is the building up process, meaning we build up something or this process is involved in the manufacturing of food for plants. And of course, that is made possible with the presence of light. So in morphemic analysis, the students have an understanding of the structure of the words and on how words are being formed. And this will allow them to have an understanding of the concept. Okay, another example is the word hypoglycemia. So the words that make up this word are hypo, which means below, and then we have the root word glyc, which is um, derived from a Greek word, which means glucose, and then we have the suffix emia, which means a condition related to the blood. So hypoglycemia literally means state of low blood sugar. So in our classes, we may provide our students with the so-called biology dictionary, which would contain different morphemes, different prefixes, suffixes, and root words that are commonly used in biology. And this may serve as a reference of our students so that every time that they read, if they happen to encounter words, they can always refer to that biology dictionary. Okay, next. So let's proceed to the second strategy. This is called anchor chart. So an anchor is a metal, it's a device which is actually attached to a boat or ship to put it in place. Or in other words, it serves as a support. So same in the same manner, an anchor chart also serves as an instructional support tool. So this can be used to display questions, procedures, process, strategies, or concepts that are important to current units of work. So we have here a picture showing how an anchor chart looks like. Now, in relation to reading, we have here an example. Let's say your topic is about symbiosis or ecological relationships. So here is a table which is um, which involves three columns. So we have here the first column is for reading, during reading, and after reading. So in here we can present this reading material to our students, but before they read that, we can ask them to focus first their attention on the title of the text, like symbiosis, the art of living together, and the picture that is being shown here. And then we may ask our students to write all the terms that they know in relation to this term, symbiosis. And then after that, they're going to post it in the first column. Then after that, we give them enough time to read the entire text. And while they're reading, we can take a pause, and then again, we ask them to write terms that they already encountered, that they already read from the text, and then they're going to post it in the second column. Then after that, they can already proceed with their readings. And then after they read the entire text, we'll now ask them to write something on a piece of paper again, but this time they're going to give a description to the terms that they have
Nanti
written,
lihat aku
which is
sama marah
posted in the
lagi.
second
Ya ora bu siap no
column
sabit saiki sik.
there. And then, so with this, we'll be able to see whether the students really understood what they have read. And this can also be posted in our board for them to see. Okay, so this is for the anchor chart. Okay, another strategy, we have the so-called wonder wheel. So in here, a wheel will be used. This is actually an instructional material made of either cardboard, which can be used by the students to spin or to rotate, and it contains questions. So how to use this in our classes? For example, our lesson is about the history of the discovery of the cell. So we may give our students a reading material, and then after they read that, we call one student in front to spin the wheel. And if it stops and it's directed to the word where, that student may construct a question based on what they have read. And then that question will be answered by their classmate. And then after answering that, that student may spin this wheel too, and it's the same process. So he will also be asking questions, which will be answered by his or her classmates. Okay, another. We have anticipation guide. So in here, we would be able to elicit the prior knowledge of the students regarding a specific topic. For example, the topic is on this essential dogma of molecular biology. So in the first column of this guide, we are going to write some statements that has something to do with specific terminologies. Like, for example, we have the word transcription. So it is a process by which RNA is copied to mRNA. So the students are going to check whether the statement is true or false. So if they think the statement is true, they have to check this part. If they think it's false, then they have to check false. Okay. And then after that, they will be given time to read an article, or maybe we could discuss regarding this topic. Then after that, they will go back and try to read again the statements written here, and they may change their initial answer. So they have to base it on what they have read. So if they think this statement is true, then they have, and if initially, for example, their answer was false, then they are going to correct it. And then for the last column, evidenced from the text, they're going to include here the statement that is lifted from the book which talks about transcription, and that will serve as the evidence of their claim, why they were able to come up with um, uh, their answer. And they may also paraphrase the words so that they will not be copying exactly what is taken from the book. So that's for the anticipation guide. And then for the fifth strategy, we call it Freyer model. So this is a graphic organizer, which help students in understanding a specific concept or scientific terms. So in here, they're going to write a term from a text that they have read. Like for example, if the topic is about photosynthesis, so they're going to write that word at the central part of the model. And then in here, in the upper left corner of the graphic organizer, they're going to define photosynthesis based on their understanding of what they have read. And then in the right corner, they're going to give facts or other characteristics of that particular process. And then in the lower part, they're going to write examples of organisms that undergo photosynthesis. And for the last part, they're going to write or give examples of organisms that do not undergo photosynthesis. So here is an example for that. Okay, so that is for the Freyer model. Another strategy is the so-called jigsaw reading. So this is a technique wherein a longer texts are broken down into smaller chunks, and the students must read and analyze the content, and after that, they're going to share it to their groups. So in a jigsaw puzzle, we connect puzzle pieces to form an image. But in here, what happens is that we break texts into smaller chunks. So, for example, in your class, let's say you have 16 students. You may divide them into 4 groups, and in each group, there will be about 4 members. So, for example, we have Group A, Group B, Group C, and Group D. So, these are their expert groups. Then, for example, your lesson is about biomolecules. So instead of giving them a reading material which contains all the biomolecules, which will be read by all the students, you can divide that into into subtopics. Like for example, um, the topic on carbohydrates may be assigned to group A, and then proteins may be assigned to group B, lipids will be assigned to group C, nucleic acid will be assigned to group D. So they will be reading the text, and then they will be answering a specific questions provided regarding the text that they have read. And then after that, they will be regrouped. So for the second round, what they're going to do is that they will be divided again into 4 groups, but this time each group will then be consisting of members coming from each group that was being formed uh, in the initial round. So like for example, we now have here group 1, which consists of member A, member B, member C, and member D. So the same is true with group 2, 3, and 4. So since they are now well represented, each one of them will be sharing the information that they have gathered or that they have learned from their readings. So for example, for group 1, member A will discuss about carbohydrates, member B will discuss about proteins, member C will discuss about lipids, and then member D will discuss about nucleic acid. So same is true with the other groups. And then From there, they can already learn all the information that they have to know with regard to biomolecules. So, as for our role as teachers, we may serve as facilitators. So we have to facilitate the activity. We have to supervise the students as they do the activity. And then for the last one, we have the four corners. So, in relation to our rooms, is it already time out? 3 minutes? Okay, po.
Yes, you have 3 minutes left.
Oh, okay, sir. So, for in relation to this one, our classroom have four corners, so we'll be using those corners to represent a specific claim. Let's say, for instance, your lesson is about um anatomy and physiology. So you may raise a questions, like for example, which among the following organ systems is the most important system in the body? So we have nervous system, circulatory system, endocrine system, or reproductive system, and why? So you may ask your students to choose their answer. So those who choose nervous system may go to corner A of the classroom. Those who are choosing circulatory system will go to corner B, and then endocrine is for corner C, and then reproductive is for corner D. And then you're going to ask them why they consider that as the most important system in the body. Then, of course, with that, the communication skills of the students will be developed. And you can also check if they understood the text that you've given ahead of time in relation to this through the answers that they will be giving. Okay, another is the so-called reciprocal teaching. So in here, the students will be divided into several groups again, and in each group, the members will be portraying a specific role. Like for example, a predictor. One will serve as a summarizer. One will serve as a questioner. The other one will serve as a clarifier. They will all read a specific text, and then um the predictor will be the one to predict or its function is actually to give his initial or prior knowledge with regard to the text that they will be reading. And for the summarizer, of course, they're going to summarize the text, and the questioner will be creating questions based on what they have read, and the clarifier will be the one to answer the questions given. And then they may take turns with regard to the role so that everybody will be experiencing how to serve as such. So this strategy may also help our students develop their um, reading comprehension skills. Okay, and the number 9, using DARTS. DARTS stands for Directed Activities Related to Text. So in here, the students will be engaged to reflective reading, wherein they will be analyzing a specific text. And there are two types, reconstruction darts and analysis darts. So in reconstruction darts, they'll be providing a missing text or arrange a scrambled text. But for the analysis darts, they will be locating and categorizing information in the text. So here's an example of a reconstruction darts. So for example, your lesson is about levels of biological organization. So the students will be asked to formulate or to construct a statement using words coming from each column. For example, we have here from column 1, we have the word the. From column 2, we have the word cell. Column 3, we have the word is made up of, or and then column 4, um, cell is the, sorry. No, column 3 is the, column 4 is basic, column 5 is unit of, and column 6 is life. Okay, so in that way, we'd be able to check whether the concepts learned from the by the students are correct based on the discussion that is given. So here are the answers. We also have here the statements about tissue, about the organelle, and about a system. So here are other examples for reconstruction darts. So they will just be completing the statements by providing the appropriate terms. So here are the answers. So this one has something to do with DNA replication. Okay, here's another example. So they will just be labeling this figure. And then another one So the students will be provided with the sentences or statements, which has something to do with the different steps in the replication. So all they have to do is to arrange this chronologically. So they have to cut this and arrange the terms chronologically. And they may also draw a diagram based on what the statement says. Okay, another. Um, for example, the lesson is about cell transport. So they will be provided with a text or an article or something to read. And then they're going to underline the parts of the passage that would explain about the movement of particles in and out of the cell. And then they are going to double underline those parts which explain about the type of particles that move in and out of the cell. Then they're going to summarize it. So it will now appear, the summary will now appear this way. All right, so we don't have enough time anymore. As always, remember when cracking the code of biology, it means breaking the language barrier that may hinder our students' understanding of biological concepts. So we have to encourage our students continue reading and understand what they are reading. So thank you very much for listening. And I hope you have learned something from our discussion.
Thank you very much for Mrs. Anja that shared to us several strategies to help students or learners to uh, tackle difficulties in language barrier related to biology concepts. Thank you very much. And we keep the question for the last session for Mrs. Anja. And now we go to the second speaker, Mr. Rotley. Mr. Rotley, time is yours. And it is similar to Mrs. Anja, 20 minutes for the presentation. Thank you.
Hello, good afternoon. Can you hear
Good
me?
afternoon. Yes,
Yeah,
we can hear you clearly. Perfect.
I will just present my presentation.
Yes. Yeah, we can
Okay,
see. Yeah, we can see it. Perfect.
thank you
Thank
very much. Okay, so good afternoon, everyone. Today, I am very excited to talk to you about using issues to discuss topics in biology and how we can integrate these issues into various stages of our lessons. This approach can help make the subject matter more engaging and relevant to students, especially when we connect it to real-world issues like ethical debates, environmental concerns, or current scientific advancements. Now, before I start my lecture, I would like to give you a gist of the objectives that I will be discussing today. First, we will describe the socio-scientific issues, explore the benefits of SSI in biology education. SSI is socio-scientific issues, and learn practical strategies for implementation. Now, I would like to start my discussion with a question. As biology teachers, one powerful way to make our lessons more relevant and engaging is by integrating real-world issues into our discussions, right? Now, let me ask you this question. Have you ever used issues to talk about topics in biology? Then, if your answer is yes, at which point in your discussion is it introduced? Is it introduced first, the first part of your discussion? Is it used as an example during the discussion? Is it incorporated as an activity? Or is it included as an assessment? Now, I will give you the discussion later on about that. But anyway, if we want students to engage with science in meaningful ways, we need to connect it to the world they live in. And that leads us to this critical question that I will be posting again. How can we prepare students for the future if we ignore the issues shaping their present? right? Now, social scientific issues aren't just teaching tools, they are the very context in which science becomes relevant, urgent, and alive, of course, for our learners. But anyway, what are these social scientific issues that I keep on talking? Now, according to Chowdhury et al. In 2020, social scientific issues are controversial, ill structured, oriented in real life situations that include socially significant with science-linked issues involving ethical, moral, economic, political, and even spiritual perspectives. Yes, the use of social scientific issues in teaching in science is not only all about the scientific concept, but we are also doing or tackling about the spiritual perspective of that concept, right? But some researchers think that SSI is the same with PBL or problem-based learning and inquiry-based learning. Actually, they are not the same because SSI focuses on controversial, real world issues with no single correct answer, while PBL and IBL, or the inquiry based learning and problem based learning, are centered on solving specific problems through scientific investigation. So that's actually the main difference between the use of SSI and PBL plus IBL. Anyway, the main question now is that why do we need to use these social scientific issues in biology education? In other words, why do we need to use issues in teaching biology? Number one is that using SSI helps deepen students' understanding of scientific concepts. By exploring real-world, often controversial issues, students engage more meaningfully with the content, and at the same time, it helps them develop essential skills such as argumentation, communication, and decision making, which are the skills that are not only critical in science, but also in everyday life. Second one is that it improves students' scientific literacy. And at the same time, it increases students' understanding about the subject and helps to improve science processes. The third one is that SSI helps students contextualize what they learn in the natural sciences. Actually, instead of memorizing or letting our students memorize facts in isolation, they can see how science is applied to real world problems. And again, of course, this approach strengthens their ability to construct and critique arguments. And last one is that it enhances their bioethical decision-making skills concerning different aspects. These aspects includes their moral, ethical, and different perspectives. Anyway, according to Hogstrom et al. In 2024, the topics that are used as of today in using social scientific issues in teaching biology are the following. They can be categorized into two actually. The first one is the environment and sustainable development, and the second category is health and technology. Okay, under environmental and sustainable development, we have the climate change, the biodiversity, the environmental pollution, and resource management. Actually, these are very common in our curriculum, specifically here in the Philippines. All of these are integrated in our curriculum in biology and in the natural sciences. In terms of the health and technology, biotechnology and medicine, the food, the chemicals, and radiation are the most common one. That is according to Hogstrom et al. In 2024. But anyway, based on my previous readings, two of the most common topics that is used for SSI teaching are under the health and technology, specifically on the biotechnology and medicine and food, specifically on the GMOs or the genetically modified organisms. These are the topics that are commonly used for the teaching of social scientific issues. But how do teachers use this one in terms of their teaching methods? According to a research, the positive effects of SSI teaching on students' competencies and motivation could in fact stem from the teaching methods used and not from the course content. Hence, SSI teaching methods are very, very important. When I talk about method here, this is a collective term that I am using for different instructional strategies or approaches in teaching SSI. The very first one is, of course, the group discussion. Okay, this involves students verbally sharing knowledge, experiences, and values. It encourages, of course, exploration, test arguments, and express their own opinions. For this to be effective, students must be open to sharing, listening, and rethinking their views. The second one, the most common one in teaching social scientific issues is through debates. This debate is different from the group discussion because in debate, the students are actually following a set of rules, right? Now, in teaching, it may involve time limits for each speaker or focus on specific aspect of the topic, ensuring a more structured exchange of ideas. The third one can be in the form of a role play. Role play involves students taking on specific roles, such as a profession or a viewpoint, to interact with others. This helps them explore different perspectives and understand the roots or conflicts of issues from various angles. Fourth one is the inquiry method, it involves students actively interpreting, evaluating, and reviewing information to understand an issue. So it may include making observations, conducting interviews, and even experiments. The last one will be the outside world relation. So most probably what they were going to do here is to interview people who have first-hand experience on that particular issue so that they can have this rich data where they can discuss the issue itself. Anyway, according to the framework of the social scientific based education, there are different key aspects in order for us to teach social scientific issues in our classroom. The very first thing that you should do is to build instruction around a compelling issue. This means that the instruction must center on a real socially relevant issue with strong ties to science, meaning that once we choose issues, it's not just a simple randomized thing that we do. We need to check our curriculum and what are the standards of that curriculum. If it can tackle the social scientific issues, then most probably we can use it. Okay, this issue should be introduced at the beginning of the lesson to serve as the learning context, not as an afterthought. That means that if we really wanted to use issues in teaching biology, then we need to present the issue first before doing the discussions. Actually, it's not really the teacher who will do the discussion, but it should be the students who will be doing it. Okay, so again, this is according to Presley et al. In 2013. This is based on the framework for social scientific based education. Fourth one is that provide scaffolding for higher order practices. Of course, since these are issues, these are not really easy. Our students need guidance, so we need to guide them. That depends on what type of scaffold that you are going to use. Maybe it is in the form of a structured activity to help students analyze multiple perspectives and form their own position. The last one is you should think of a culminating experience. What is that activity that you're going or let your students do? Is it a debate? Is it a role play or project? But uh, anyway, whatever culminating experience you're going to use, it should encourage the students to share their own thoughts and reflect the competencies of the curriculum that you are using. For example, this is only an example. If, for example, you will be using the genetic modification as a social scientific issues in teaching. Now, in the Philippine context, genetic modification is under the Matata curriculum. This is on the grade 10 students, and for the K to 12 basic education curriculum, this is in grade 11 or grade 12, if I'm not mistaken. But for example, you chose genetic modification to teach as a social scientific issues. I will always point out that we are teaching scientific concepts as a social scientific issue. Okay, so for example, the first step, does genetic modification clearly connect to the biology topics I teach? And is it a socially relevant issue for my students? Of course, we need to identify if it is relevant to our students. In our case here in the Philippines, the introduction, for example, of BT eggplant or the BT corn, we can use that as our point of reference so that students can relate to our topic. And then, am I introducing genetic modification at the beginning of the lesson to frame the learning experience? Just like what I said a while ago, you should present the issue on the first parts of your lesson. You provide scaffolds for higher order practices, which you can ask yourself, Have I provided support or guiding questions to help students argue, reason, and make decisions about genetic modifications and the culminating experience at the end of the lesson? Will the final activity allow students to reflect and apply what they have learned about genetic modification? Now, these questions can be asked, you can ask it to yourself because these are reflective questions. Okay, anyway, for example, you have assigned them to do role playing or debate. You can assign students who will become scientists, others will become farmers, others will become consumers, the others will become environmentalists, and I'm very sure that they have different perspectives on how they see genetic modification, specifically the production of genetically modified organisms. That is only an example. Now, for their tasks, you can give them research, position papers, or debate panel. That depends on the competence that you are targeting. Anyway, this will be the uh, uh, last slide for my presentation today. I would like to end my presentation with the challenges because I believe once we know the challenges in SSI teaching, we will be able to produce materials for other teachers also to use. And I think this is already a gap in research that we can do and create our own research SSI-based teaching. Now, number one challenge in teaching SSI is that it is our teachers tend to be, the classroom tends to be teacher-centered in terms of teaching. Now, the research by Sadler and Lee and Young highlights that many educators struggle with shifting from traditional teacher-centered instruction to more student-centered, which, for example, is this SSI inquiry-based approaches. This shift requires a new set of skills and strategies that they don't actually like it to shift from this type of teaching. Number two is that they have insufficient knowledge base. According to Liden et al. In 2017, many teachers lack the comprehensive knowledge base in both science content and social sciences. In other words, they are trying not to use SSI in teaching because they know they have very low confidence in teaching it. They don't have that much content knowledge about the topic, thus they don't want to use it. That's the simple description of it. Okay, SSI requires teachers to be well versed not only in the science but also in the societal, the ethical, and the cultural implications. Thus, they need to have a very high knowledge base about specifically the content knowledge. Number three is the discomfort with ethics and values integration. Now, according to these researchers, teachers often feel uncomfortable when it comes to integrating ethics and values into their lessons because, in the first place, it is science, it is concept based. That's what they're thinking, right? Discussing the moral implications of topics like genetically modified organisms or climate change can be challenging as it requires navigating sensitive issues, right? Number four is that they have this fear of classroom management loss. That means that they cannot facilitate the classroom well. If specifically, for example, they told their students to do their debate, but they don't know how to facilitate debates at all. So that's already one of the problems of the teachers in different research studies. When students are encouraged to express their opinions and debates, it can feel like a loss of structure, which makes some teachers hesitant to adopt this approach. And second to the last, we have the content time prioritization. And based on these researchers, the pressure to cover the required curriculum in limited time can lead teachers to prioritize content knowledge over the exploration of SSI. That means since our curriculum tells us to teach many concepts, so they tend to just simply teach the concept and just be it. Okay, they don't want to use SSI because it will take too much time for the students to do their activities. This often results in a focus on traditional science teaching rather than engaging students in real-world issues, which is connected to the first one. And of course, the last one, this is uh, I've been reading many studies regarding this one, that one of the constraints in teaching socio-scientific issues is because of their religious belief. Don't you know that some parts of the Philippines, they believe that uh, uh, genetically modified organisms are actually scary things, and since it is not natural, so we are not obeying the God's law, just like that. Okay, they have this idea of being limited by the religious belief. Anyway, uh, it can influence how SSI is taught. As noted by Franz et al., some communities may have strong beliefs that conflict with the teaching of certain SSIs, creating barriers for educators. So just like what I said, even though these challenges are significant, they also present opportunities for growth. One of the research that I also read is that one of the problems also of not integrating SSI in biology education is the lack of materials. So we need to produce more materials, study more about SSI-based education, because this is a very student-centered approach. And that's already the end of my discussion. Thank you very much for listening, and good afternoon.
Okay, good afternoon, and thank you for the presentation. Really wonderful presentation for Mr. Rotley about socio-scientific issues, especially targeting biology topic. Okay, so we have concluded that we already listened to speakers, to wonderful speaker for the first session. Now we will move to the next session, Q&A, question and answer. So to all of the participants, you can ask your question either for Mrs. Anja or Mr. Rotley. You can type it in the chat or you can ask directly to the speaker. You can ask in English. In Indonesia, I can help you with that. But if you ask in Tagalog or Philippines, I'm sorry, I cannot help you. Just ask the question to the speaker directly. Is there any question? We have around 15 minutes for the question and answer Q&A. Okay, probably I have a question for Mrs. Anya first. You explain to you about several strategy how to cope up with biology concept. For example, like the how student understanding words in biology to reflect their understanding and so on. Probably because we already have a lot of pre-service teacher in here in Indonesia, in our institution. Our student is to be mostly to be a teacher in the future. So maybe you can give some tips or some insight, maybe how to implement or combine several strategies as one, so we can have the more comprehensive results to understand biology concept. Yes, Mr. Anja, can we, like the combine or use 2 or 3 more strategies as one, as you explained, like the jigsaw or reciprocal teaching or anchor word, and what kind of probably like the obstacles or opportunity that the teacher may be faced during the implementation of those strategies.
Hello, sir. Good afternoon once again. So regarding your question, regarding the use of those strategies,
Yes.
one of the challenges that we might experience when we use that as teachers is maybe the time constraint because uh, of course, most of the time we want that whenever we discuss things, it should be discussed within a given period of time. But with these activities, we might be challenged because of the time. We really need to allot more time for that. And one thing more, of course, we have to make sure that when they are having, when we're doing that activity, like in reciprocal part wherein they will be portraying a specific role. Some students might have misconceptions of what they've read, and they might not be sharing correct information. So it's our role as teacher to guide and to monitor the students as they do the activity.
Okay, thank you for the answer. I hope it can give us like some information or some like the new additional insight about how to cope up and implement this kind of strategy. And I think it's really important for teachers, for us, for our student who will be the teacher in the next future, how to uh, tackle the language barrier related to biology, because somehow when we have to explain some term in biology, it's really hard to make student fully understand what it is and how it can be explained in the real context. Is there any question? I we have some time, like probably around 5 or 10 minutes for the question and answer. Probably I have another question as well for Mr. Rodley. So, Mr. Rodley, and for the socio-scientific issues, usually my in my research, I'm really focused on problem solving. I use like the well-defined, sometimes I use ill-defined problem solving in our research, but I really interest for the socio a scientific concept, because I use a scientific more rather than integrating to the social context. So, what do you think when we try to develop or introduce scientific, socio-scientific concept, and do you think there's some proportion how much the scientific part and how much the social part? Because when we talk about socio-scientific, that should be something related to the human behavior or social impact.
Yes, actually, the planning for the use of SSI in education is very time consuming because we need to plan ahead of time because we need to identify the competencies that are aligned to it. And again, one of the problems that based on the studies that I have read is really on the time also. They need more time to do it. They need more training to implement it. And of course, it's really on the planning and on the content depthness of the teachers in order for them to properly implement the approach of teaching it. And in terms of the proportion, I think we really need to plan ahead of time on how much time are we going to allot to it, because I think when we teach social scientific issues we can already tackle most of the competencies as long as it is properly planned and integrated in our lessons. I think that's one of the suggestions that I can give.
Okay. And what do you think about our issues in our environment? Do you think we have to include like the socio-economic or scientific issue, natural issues in our environment first or in the global first? What do you
Well,
think?
maybe I think that already depends on the kind of students
Uh-huh.
that we have. But in my point of view, I always start from the global issue until
Uh-huh.
going to the local issue so that students can have this uh, bigger picture of what is happening and how is it related to their lives as it is contextualized in their own learning.
Okay. Okay, thank you very much. It's give me like this some really nice input. Especially for me, I try to like develop some research relating to biology as well, but more like to educational approach related to problem solving. Sometimes we want to include some local issues or global issue, but we have some difficulty how to like the go with the flow from the global first or from the local approach first. So thank you for the information. Is there any question for the first session for the two speaker?
Sis,
Oh, yes.
yeah, I want to ask.
Okay. So Mrs. Ipa, yes.
Yes, thank you for the opportunities, and thank you for the great presentation from Mrs. Anja and Mr. Rutley. I want to ask to Mr. Rutley. We know that not every student has higher order thinking skill, which is good. How to facilitate students with low of higher order thinking skills to analyze or solve problems about socio-scientific issues. Thank you, Aziz. You get the question?
Yes,
Okay.
yes, thank you.
Okay.
Thank you
Mr.
very
Rohit,
much.
yes.
I think
Okay, thank you.
yes, thank you very much for your question. I think one of the suggestions that I can give you is that first you should diagnose your students. Who among them is actually on the lower part and on the upper part, and then group them based on their abilities first, so that the good, I don't know the term that I can use here, but let us group them based on their abilities so that some students can teach the other students too, and who knows that it can benefit them because they are grouped depending on their abilities, and they can teach their classmates too in their point of view. And I think that's a better option if we are having problems with the students who are having difficulties in understanding these concepts. Yes.
Okay. How is it, Mrs. Siba?
Okay, thank you, Mr. Rutley.
Okay.
You're
Thank you very much.
welcome.
Thank you very much for the question and also the responses for Mr. Rotley. Is there any question for our incredible two speakers for the first session today? Okay, if there's no more question, I would like to say thank you very much for Mrs. Anya and Mr. Rotley for very interesting and beneficial information from the presentation. And now we go to the second session for this lecture series today. For the second session, we have two incredible speakers as well from Universitas Persatuan Guru Republik Indonesia. The first speaker for the second session will be Mrs. Fanny Rosayanti. Mrs. Fanny Rosayanti is like the associate professor in the magister program for natural science in Universitas Persatuan Guru Republik Indonesia, and also the head of the Institute for the Individual Development. And our second speaker is Mr. Prasetyo. So Mr. Prasetyo is also the assistant professor in the Department of Biology Education in Universitas Persatuan Guru Republik Indonesia, Semarang. Okay, so we have two speakers. Now I would like to ask firstly for Mrs. Ferry Rosayanti.
Okay.
Good
Can you hear me?
afternoon, Mrs. Fanny.
Good
Yes.
afternoon.
Okay, Mrs. Fanny, you have 20 minutes to present your topic. So the floor is yours.
Okay, thank you, Ajis. May I sharing?
Yes, absolutely.
Wait a minute. Hmm. Sorry. Can you see my slide?
Not yet. I cannot see
Wait,
your slide. Maybe you have to
wait a
refresh
minute.
yeah.
Hey, somebody help me in my room. So many file here. I forget to put my files. Where is this? I'm sorry. Wait a minute.
Okay. We will patiently waiting for that.
So somebody help me maybe in my room. Wait a minute. Okay. Udah ketayangan ini, tapi kok nggak ke sharing ya? Kan di file tabnya. Filenya tuh yang mana gitu. Tapi sudah tertayangkan. Tapi saya masih lewat ini juga ya. Oh, bisa tertayangin ya? Oh, pasti nggak apa-apa.
Okay, I think there's some technical problem for Mrs. Fanny. Probably we can jump to the second center, Mr. Prasetyo, and probably Mrs. Fanny will be the last speaker for today. Mr. Prasetyo?
Okay, Pak Aziz.
Okay, thank you very much for.
Okay. I'm
Yes,
start dulu, Pak Aziz.
we can see the presentation.
Okay. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi
Good
wabarakatuh.
afternoon and best wishes to all of us. Dear Mr. Rodley, Miss Hanja, Miss Fanny, and participant in the International Joint Lecture Series. Thank you for your time to on this occasion. I try to convey about how to construct learning with a socio-scientific issue for sustainable development. My presentation begin Indonesia and the Philippines have similar characteristics. The similarity can be seen from several things. For example, is Indonesia and Philippines is archipelago country, and we have a volcano visibility about tropical zone and natural world about biodiversity. I think with such characteristic natural condition, the all citizens hope to have a prosperous life. Currently, all countries in the world, including Indonesia and the Philippines, have the same problem. For example, is employment and then economic. Data from 2025, employment in Indonesia reached 4.9% and Philippines 4.5%. And economic, not all citizens have a stable economy. With this problem, the government is trying to overcome them by creating jobs to the use of natural resource. For example, is conversion of forests, deforestation, and then mining and industrial development. From the government's effort, there is no escape from the impact on the environment and people life. For example, impact is pollution, environmental damage, and socio-cultural change. Pollution is the introduction of contaminant or harmful substance into the environment, affecting land, water, and other natural elements. And then pollution has harmful or patient effect on the environment and living organism. And the Industrial Revolution significantly contribute to environmental pollution as we know it today, with population growth exacerbating waste management issue. And then environmental degradation caused by natural and human factor. For example, decreasing source of clean water and decreasing source of clean air and decreasing soil fertility. The environmental damage give impact on the sustainability of life. And then impacts, the third is socio-cultural change. The socio-cultural change is a dynamic process affecting various aspects of society, including social structure, institution, and cultural element. This phenomena is largely influenced by advancement in science, technology, and media, which bridge the gap between macro and micro-social and cultural level. For example, socio-cultural change, the shift from traditional livelihoods, especially agriculture, to employment in the industrial sector, and lifestyle and decreasing level of social involvement of the community. The shift lifestyle, for example, is shift food from the traditional food, and then the GMO. Based on the various world problem in 2015, world leader officially received the Sustainable Development Goal Agenda with 17 goals, including, for example, is no poverty, climate change, live below water, and etc. With the current world condition, we all must instill in our mind and conscience that the earth is not only for the current generation, but also for future generation. I think we remember the advice, the earth is not only for the current generation, but also for future generation. What is the solution? What does the world need? The world need people who have the knowledge, skill, and motivation to address any problem. For example, is literacy environmental or health literacy, and etc. And then as educator and prospective educator, what contribution can we make? Among the contribution we strive to make is to equip individual with the knowledge, skill, and motivation to overcome any problem. The individual are individuals who have literacy skill. For example, is environmental literacy, health literacy. And the way to release this effort is truths, education, and learning. Some recommendation. Learning alternative include, for example, is problem-based learning, project-based learning. Indonesia is pembelajaran berbasis kelanjutan, PBIB. Belum ada bahasa Inggrisnya Pak Aziz ini. Di Inggris kan Pak Aziz.
It is like lifelong learning, something like that. Yeah.
Okay. And then socio-scientific issue.
Yeah.
Socio-scientific issue is a learning approach that use unstructured issue with open, complex, and argumentative future dimension at the same time, have scientific and social. And then socio-scientific need three core aspects. Number one is design element, and then learner experience and teacher attribute. And how social scientific issue intervene in sustainable development. I will to try to construct how social scientific issue intervene in sustainable development. To construct, I need number one is learning outcome, and then learning approach, learning model, and learning method. For example, in Indonesia, learning outcome link climate change to biodiversity in the present and past. This structure document curriculum in Indonesia. And then I need SDGs about climate action. For example, is climate change adaptation. And then I need topics for issue for SSC, social scientific issue. The characteristic is science and social. And then I need learning model and a learning method. To design the learning outcome, for example, Indonesia in the high school, senior high school, is link climate change to biodiversity in the present and past. And then the example SDGs is climate change, the climate action, and for example, climate change adaptation. And the activity in climate change adaptation, for example, is protect yourself from heat stroke and dehydration, using water, save water usage, collecting rainwater, spreading knowledge about the climate crisis, and etc. And then the SSC issue sign is global warming and social impact on human life and other living things. To give about learning experience a student, I need a model, pembelajaran or learning model. For example, we can use to PBL, problem-based learning. Problem-based learning have a syntax. Number first is problem orientation, organizing student, guiding student investigation, developing and presenting the result, and analyze and evaluate the problem solving process. If you use the learning model for the in step by step or syntax, for example, a problem orientation, we can to intervene about high order thinking but in the SSE, uh, intervene argumentation and higher order thinking skill in student, and then the organizing student, intervene to hot, guiding student investigation, hot, and then developing and presenting to intervene about argumentation and HOTS, and then analyze and evaluate the problem solving, intervene about argumentation and HOTS. And then the last slide, Pak Aziz. I this show the synergy between the curriculum, SDGs, and then SSE. The document curriculum in senior high school in Indonesia in biology in link climate change to current and past biodiversity. And then SDGs addressing climate change, for example, is adaptation to climate change. And SSE, for example, science is global warming, social impact of global warming, argumentation and higher order thinking. And then expected result, students who have knowledge about climate change, impact and health adaptation, and then students have the skill to adapt to climate change, and students are able to solve problem with climate change. And this, finally, I wish you a happy Earth Day and terima kasih. Matur nuwun Pak Aziz.
Thank you very much, Mr. Prasetyo. Yes, you remind us about today is like the Earth Day, like 22nd of April. So everybody, happy Earth Day. I hope our Earth will be always in a good condition as well. In a good condition. So Mr. Prasetyo present to us some information like the similar to Mr. Rodley about socio-scientific issue, but how to construct it with SDGs or Sustainable Development Goals from the curricular perspective into learning approach. So thank you, Mr. Prasetyo. And before we go into the last presenter, the last but not least, Mrs. Penny Rosanti, I want to remind for all of the attendees, we have like the link for attendance and we will share it into the chat room. So please fill out the link and make sure that your attendance will be recorded by our team and the committee. So next we have the last but not least presenter and speakers for today's event. We have Mrs. Fanny Rosayanti. Mrs. Fanny, yes.
Okay, thank you. I'm sorry for what's happening before. So this my impression. About my slide, it is okay?
Yes. Okay, we can see it now. Yeah.
Thank you for community of the biology lecture series 2025. I will so proud to presenting about STEAM in biology teaching and learning. So my research about STEAM is almost maybe 15 years, and I will sharing to all of you. We will talk about how implementing the STEAM in biology education or biology teaching and learning. So I'm trying to guide you through a more engaging, interconnected way to explore and wonders of life. We're not just going to memorize fact as say with Mr. Anjay. It's hard for us to understanding biology because so many terms, but we will going to experience with biology through a STEAM lens. So what does STEAM based learning process in biology actually look like? is not a rigid set of rules, but rather a flexible framework that embraces the interconnectedness of science, technology, engineering, art, and mathematics. Okay, everybody knows STEAM is an educational approach that integrated this discipline into a cohesive and interdisciplinary framework for learning and problem solving. So it's the red one. I use problem solving, but important for us to problem everything with STEAM. The STEAM approach builds you upon the foundation of STEM education without arts, but today by adding the arts component, which include disciplines such as virtual, visual, or music theater, or etc. About the arts is integrated with science and technology, engineering, and mathematics. So the goals of STEAM education is to foster creativity, thinking critically, innovation, and well-rounded understanding the world. Okay, so we will start to talk about STEAM. It is use science, technology, engineering, art, and math as access point to guiding student inquiry, dialogue, and critical thinking. Of course, creative thinking. So this step up the classroom, but we'll talk about later. I will let talk about the essence of a STEM-based approach in biology learning is to encourage you to ask meaningful questions, connect biological concept to other discipline, think creatively and critically, solve a real-world problem, communicate your understanding in deserved ways. So throughout this lecture, we will be actively engaging in this step. Get ready to explore biology not just a subject to be studied, but as a vibrant and interconnected part of our world, ripe for innovation and creative problem solving. And we talk about STEM-based learning in biology, so we have to thinking some explaining for the educator, for a pre-service teacher, in-service teacher. So the first one is introduction, setting the stage of STEAM in biology learning. The significant development this movement in the images for STEAM education, which build upon established STEM and put arts, so we call STEAM with art. This integration knowledge that creatively artistic thinking are not isolated, uh, but are in fact essential component innovation and problem solving for all fields, including science, technology, incorporating by disciplines such as visual art, music, design, humanities. STEAM aims to broaden and scope of learning, encourage imaginative solution, and provide more meaningful education experiences for the student. So we have to understand because the STEAM today is put so many arts in how we will to solving the problem. The second one in we have to understanding STEAM education in context of biology, especially the definition, and then we talk about core of STEAM. Core of STEAM is biology. Not only use our biology as a discipline, but we have to integrated biology with five disciplines, not about separated entities, but as interconnected between science as a biology and then technology and then engineering, art, and mathematics. So here we have to give some interdisciplinary to problem to solving the problem. And then we have some principle that we will call the principle is a core of how to implementing the biology in STEAM. We talk the first is about focus, and then we talk some principle we talk integrated discipline,
Final
and
exam
then
from last week, April.
okay, I'm sorry.
Mhm.
Always somebody walk talking. Okay, we talk about focus and then discover and then how to application and then presentation. So we can talk about STEAM, but we thinking what the biology context to solve the problem, the biology problem, and then we use another discipline from technology, engineering, art, and math. The first is integrating a STEAM element into biology lesson and activity. Of course, we have to thinking what will the context that we will put as a project. The project is as to problem. So many daily problem and student. We conducted with a project with some project. We talk about so many uh, term, yeah, of disciplinary. For example, we talk about, of course, science is a biology, and then technology. For technology, we will how the student use so many instruments, so many uh, equipment that help the student to solve the problem, and then the student have to use how they thinking about design process, how the student can make the real product before they're designing the prototype of product. And then for the next one,
Do you
find the
have
product.
do you
The
have
student
online cards?
to make some
I mean, at that.
arts as touch, and how the product is so interesting for everybody to analyze, so to show the product, and then of course the student have to mix the product is with so many art touch, and the final mathematics the student have to use um, mathematics, for example, proportional, that it is important to thinking how mathematics can be used to student to make the problem it is work it. And then the example of study-based project is activities commonly used in biology education. I will talk about the five one in the and then we will talk about pedagogical benefit from student approach in biology learning. Of course, it is can make student deeper understanding. Not only they understand about the concept, but a student can make so many activity, and uh, especially for kinesthetic student, they like to make some. They like to moving to everywhere. That's important to kinesthetic student to make. They always have activity, and then of course
Yes.
this understanding what they learning about the biology. The seven is potential challenges and consideration when implementing STEAM in biology. Of course, so many potential challenges and consideration. Then, when the teacher implementing the STEAM, so Mr. Rodley already talking about. We have challenging with the time. We have challenging of the facilities. So it is important for us to thinking. What kind of STEAM that will be implementing in the school or with the facility that the school have. The 80s resources and guide educator on designing implementing STEAM-based biology lesson. So This is important for all teacher, pre-service teacher and service teacher that use so many resources from internet or from community that we talk all of about STEM and how to implementing in our class, and we have to sharing best practice between teachers, and of course the last one is STEM in the transformative power, especially in biology education. Okay, everybody, it is so many project that you can choose in your project team or student project team. For the first, we talk about modeling value structure, designing sustainable ecosystem, creating digital art and animation, developing bio-inspired design, conducting data analysis and biological phenomena, it's producing scientific illustration and infographic, creating educational games and simulation. For the next slide, we will see these so many examples that we can use to implementing STEM in biological learning or student project that we can choose modeling blood structure. We can asking your student to designing the models of anatomic from animal or from human, and then the student we can use plasticine or in biology education and UCRIS, we already asking the student to make anatomy of fish and use some kind like wood, and the student make some organ with use wood. And today I asking my student to make some human organ with use some kind of model, yeah, and then we will make a model with some so many graded. And this is a modeling structure from plant. We will use a plant that maybe it's herbarium, but not only in use in the book or a paper, but make some artificial or artistic wall. Yeah, can make your room a little bit fresh. And then my some student already make some flowers with agar-agar. What is agar-agar? In English. With injected jelly. Yeah, yes. Jelly and injected so many size, so many this already to understanding what it is petal or flowers, models of structure of petal flowers. You can unlearning with use make a jelly, interesting jelly. We for eating the jelly, I not sure we ready to eating the beautiful jelly, with so many flowers, beautiful flowers. And then designing sustainable ecosystem. We can asking the student to make a project about eco column. First of all, the student have to writing or have to drawing what they planning about the eco column, what kind of every surface or every plant or animal, what will they put on every kind of ecosystem, and students have to try to sustainable ecosystem for a long time, already 1 week, 3 weeks. It depend on how the student make already on the eco column. And the next project, the student can make some project with animation project, use some many application in internet, make some IT game project. It is important to student to understanding so many biology process, but it can make with an animation. So not only understanding the process, but the student so have the models how the process or the biology process will going in animation in this animation. Another projects the student can make game tools, creating educational games or simulation. You can make game board. Game board in my Philippines, I don't know what we the term of the board the board games in Indonesia. We talk about ular tangga, ular is snake, yeah, and step. So so many questions put on the board games, and then the student use the rule of the games, and they understanding the concept that acting in the board game, or make card games, quartet, or equipment of the games. That is so sample, yeah, for make equipment of games, or make a simulation. Uh, this project, student that make project, not teachers, yeah, not a teacher and then teacher use with the student, no, but the student already you makes a project of educational games. Okay, another project is creating educational game with simulation. So many project that how this picture show that how the fish have what we call inside the body of fish, ya, gelembung renang, ya, that can make uh, fish can swim, yeah, at middle it in deeper of the pond. Okay, and then we can use project producing scientific illustration or infographic. Maybe you asking student to observe some environment around the school, and then put so many data, and then analysis. So make some information with maybe a book or infographics, anything, but put the data of our observation report as more interesting, that not only about just a report, but the student maybe make some poster or a book project. Is the school will have, or so the teacher will have so many resource to teach uh, about biology. And the last one, maybe you know batik, yeah, batik from Indonesia. How come the project to make a batik can use to understanding biology, especially for biodiversity? The project we will use ecoprint, and you can see batik to make a batik, yeah, so many steps, but the teacher can use information from so many leaves from plant, and analysis maybe it is going to monocotyl or dicotyl, and a student analysis the characteristic about I mean the lips, and put on some fabric, and use to push, and then make some pattern, and the fabrication, and make this we call eco print. Not only talk about for example carica papaya, we have look like a finger, support pattern in urban of leaves, but we will have a fabrication with so many leaves that we can analyze about the biodiversity. For it is my research already at from early childhood and then at uh, sekolah dasar. This around level third. I mean make some hydroponic. They already designing for the first what kind of plant that will they used to in hydroponic. So how much the uh, bin of the rock wall, how many they will counting, and then they will measuring about the pH. Everything use the facility of school and student already uh, make hydroponic uh, from seed to harvest, yeah, to harvest. And then the student make what it is some of field and school put some plant and then analyzing what kind of plant they planting in the field. It is another project how plant is growing up. How about symbiosis and a student? I mean, it is fourth level, fourth grade. Make a pop-up book from task, yeah, from STEAM project. It is the STEAM project, another STEAM project. It is my research, and it is the last research about mitigation, STEAM for mitigation disaster, and it is for junior high school and in science education on biology education. The student and the teacher try to make retention phone to solving the problem for rock or flood. Okay, Mr. Ardis, it is all of my presentation. I'm sorry for everything. So how can understanding of all of you. Thank you, Mr. Adiju. Terima kasih. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you, Mrs. Penny, for very interesting presentation. It is about the STEAM in education, like the integration of science, technology, engineering, art, and mathematics. Okay, so the two of our speaker in the last session has been presented their topic. So now we will go into the Q&A session, question and answer. So for all of the participant and attendees, if you have a question to one of the speaker or maybe to both speaker, we have time for you to ask your question. We have approximately like the 10 or 15 minutes for the Q&A. So if you have a question, don't hesitate to ask your question. Maybe you can type it in the chat or just directly ask your question to the speaker. If you want to ask your question in Indonesian, in Bahasa, I can help you with that. Don't worry. Or you can ask in English. It's also fine.
Okay, Mr. Aziz.
Okay, Mrs.
May
Sipa
I begin?
again, please. Yes.
I'm sorry. Okay, thank you for the great presentation from Mr. Prastyo and Mrs. Feni Rosayanti. So interesting. Now I will ask and my questions direct to Mrs. Feni. Okay, Mrs. Feni, so interesting for seeing many examples of STEAM projects. I have two questions. First, as a teacher or lecturer, how to connect one aspect with another aspect in STEAM? Any tips, maybe?
Okay.
And the second is, can all materials use a STEAM approach? Because sometimes we think that one material is suits or match with STEAM, but sometimes I think another material is not suits. How do we know that this material is suitable for STEAM? Thank you.
Okay. Thank you, Miss Ipa. Okay. Miss Ajis, maybe I forget one slide that I have to explain how to implementing STEAM step by step in
Yes,
the
yes.
biology learning, some step. But the important thing, the one important that a student or I mean a lecturer or a teacher that will implementing the STEAM, the first to analyzing how the material that suitable to use a STEAM. Uh, Not so all biology material can using for a STEAM because it's hard to make a project, but uh, so many material biology that we can use in STEAM. For example, in my major is about human physiologies. It's hard make a project already about the process or, but we can asking the student to maybe make some simulation or models of biology or physiology process, and this make to student to analyzing what kind of product that will be conducting, there will be development, because you as a lecturer have to what the goals of your lecturer, your course. If your course is may make a student understanding of the process, so you can use another a project to understanding the process. But if your career your goal is student can have so many skills, you can use STEAM. The first for of all is thinking and understanding and analyzing what kind of material that sustainable sustain of STEAM. Maybe in your major, you can in biology, you can choose the perfect one that it is important to make a produce a product. This Miss Ipa, and the tips is maybe you can so thinking creatively, thinking creatively uh, before you asking the student, you have to analyzing it is can the student make this product or not? What time we have to planning for this project, for example, like that. And the second question,
Yes, we
what
have another
you can,
question.
yeah, the second question for Miss Ipa, Miss Ajis, I forget it.
Yes.
Uh, may
Okay.
please
Yes.
the second question.
As a teacher, as a teacher or lecturer, how to connect one aspect with another
Okay,
aspect in STEAM approach?
okay. Okay. So before you asking a student to make a project, you have to thinking the aspect of five discipline of the STEAM. So maybe you asking the student to for my project make human organ system models, 3D models, the small one. I just thinking the technology that can student use are searching about the material that can use to make a model maybe from plasticine or make from another material, and then okay, engineering, they have to drawing first, and then the proportional. Maybe they will make a sum of hurt, but the proportional it is for so real, or 1:10 or 1:5 for the measure of the heart. And then we have to just thinking about engineering and art. So student have to painting the real painting, the colors is the real colors, what the heart is look like. And the last one is a mathematics too. So you have they have to make size of the hearts. It is already the real one. For example, the what it is part of heart. It is have to proportional. Each and the other is so. After we thinking about that, you will asking the student to make a project. If you're not thinking about all comprehension of what integrated the discipline, just asking the student the project, you can you can driving the student how to make to solving some problem if they have facing the some problems. So the first one, the teacher or the lecturer thinking of the project comprehension, and then you alternative you will coming up with the problem, and you can asking the student to make a project, just not like asking the student to make a project and then you don't know what next the student have to do. Okay, maybe this answer for the Miss Ipa question. Miss Ajis, thank you, Miss Ipa.
Yes, how is it, Mrs. Ipa?
Thank you for
Yes,
the explanation. I will practice it in my major, Mrs. Freddy. Thank you.
yes. So in STEAM education, there's a chance to integrate all of the elements together as one in one project. And we have another question as well through the chat. Maybe I will read it. So this is a question for Mrs. Fanny. And the question is, how might the skill developed through STEAM education can prepare students for their future career in biology-related field?
Okay, thank you. So in my experiences in STEAM research, we're facing so many problem in STEAM, especially in school, because so many teacher said to me it is hard for us to implementing STEAM because the time, the facility, and the teachers thinking it is hard for student to make a project because teacher just thinking it just task for the student, not the project. Nah, STEAM make student uh, thinking creatively, thinking critically, and then they can make some project with some designing first. It is important for a student not only make apa from a teacher just tasking. It is important because if student, for example, teacher asking student to make for water clear water, and then student reading from step to make a project. First, you have already with blah 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 blah, and then step or you first you can put type or everything already in teacher guidance. Student only reading and doing, not thinking. But the project is already different with the step. The project, especially for a STEAM, students have to thinking it is about what? It is about the pollution in water, how to make clearly the water clearly with some equipment, and then student just thinking what will design of your equipment to clear the water. Student thinking maybe we use pipe, the different size, small size, the big size, and then the drawing, and then the thinking, the searching, what kind in internet about the equipment to clear the water. Not only use the step that's teacher facility. That is makes student thinking critically and then creatively because so many material can use to clearly the water. Each group with another is different way to make this product is okay. So this is the thing that student can make skills, not only just thinking, but they have to implementing the designing with the product and then sharing with another's what kind of product with another groups and then okay we have to make more better than another product, another group product. So it's important to have skill that the student will use the skill in for long lasting and for long life in her day life. Yeah, that's important for a teacher to give opportunity, so many opportunity to students to developing their skills, especially in offline learning. That is the answer, Mas Azizul.
Yes,
Uh,
I can
okay,
conclude that
please,
like this. Yeah,
yes,
that
yeah,
same
please,
education.
different way, different thinking between tasking and then project is a different way to thinking for the student.
Okay, so we can conclude that through the STEAM education, student can develop several skill set like the
Yes,
thinking skill, like the communication skill, and other skills as well that can help them in the future when they are, like they're working in the real life or working with the other people as well. They can implement what they got during STEAM
yes,
education when
okay.
during in the learning session and so on. So I hope we can answer the question and maybe another question as well for our incredible speakers. Yeah, probably I have a question for Mr. Prasetyo. You explained to us about SSI, about socio-scientific issues and how it connect to SDGs, Sustainable Development Goals. Maybe you can give us the tips. What kind of things that the tips how we can integrate it well, because somehow it is hard for us to think about all these scientific issue and how it can be benefit for the sustainable development. Maybe you can share to us what kind of tips and sharing the experiences like the obstacle or maybe the benefit, how to incorporate all of them together. Mr. Prasetyo?
Okay, Pak Aziz.
Yes.
Yeah, Pak Aziz, for example, to integrated uh,
Yes, exactly this slide.
scientific issue and SDGs, and then sustainable development goals. Uh, we can to use framework from SSE. In SSE, we use the topic, for example, about science, and then impact topic to social. For example, is science global warming, and then social impact is of global warming, and we can to relate in SDGs. And for example, in SDGs, have 17 goals. For example, is climate change, and the climate change we can to use about adaptation to climate change, and SDGs and SSC in Indonesia we can to link in document curriculum. For example, is climate change to current and past biodiversity. And integrasi in the curriculum SDGs and SSC, uh, the expected result to intervene to student, for example, is knowledge and skill, and then uh, students are able to solve problem. And we to integrate it in the SSC SDGs and the curriculum. I think we can to uh, remember the advice, the earth is not only to a current generation, but also for future generation. And I think if we integrated SDGs and SSC, we can to uh, the people who have knowledge, skill, and motivation to address any problem. And we hope if we integrated SDGs and SSE, we can to contribute to success and SDGs, and then we will to save the planet, and we and generation we apa namanya Pak Aziz ya, tuh hidup sepanjang masa ya untuk bumi ini.
Yes.
Ya, jadi tidak hanya untuk kita saja yang saat ini menikmati bumi gitu ya. Ini generation about juga untuk future generation.
Okay.
Ya, maybe
Okay.
itu ya Pak Aziz ya.
Yes. Okay, Mr. Prasetyo, maybe I can conclude that we can integrate like the SSI, socio-scientific issues, with SDGs. So we have to really define what kind of issue that already become our chosen topic, and we have to link it to the 1 or 2 point of SDGs. We have several SDGs aspect. We have to link one of them into one of the SDGs and make sure that everything that we have built on should address the benefit also for the future generation as well. That's the main point, to save our life in our present days and also in the future for our next generation. Okay, thank you, Mr. Prasda, for really insightful information about SSI and SDGs. So I'm back to the all of participant. If you have any question, we have still several minutes left. Okay, if you have no question, so no question no more. So maybe I can conclude today's event. So we come to the end of today's seminar, and likely I want to thank to all of the speakers for the valuable insight, experiences, and the topic today. I want to thank you for all of the participants for your active participation and for your time to listen to us during the first until the last meeting for today. I hope the discussion today inspired us about the new thought, experiences, maybe ideas for upcoming research or academic approach, probably for our future. I hope it can be give us some benefit for all of us. And I want to tell you about the information in this series. We have like the certificate. For the certificate will be distributed after all of the session have been concluded. So please stay tuned on the information in the WhatsApp group, because we will share all of the information related to this event in the WhatsApp group. And don't forget, on the next session on Wednesday, Thursday, and Friday, we have upcoming session as well. We have 3 more lecture series. So please don't miss the series, because we will provide you another incredible speakers as well. So to end of today's session, I officially close the lecture series today. Thank you once again for your participation. Thank you for a wonderful speaker. We have Mrs. Anja, we have Mr. Rotley, we have Mr. Prasetyo, and Mrs. Veni Rosayanti. Thank you very much. I hope we can see all of you again, maybe in the next event, online or offline, between both university. And I hope in the next future there will be more events that involve both of us, UPGRIS and the MMSU as well, online or offline, in academic or in research. So thank you very much and have a good day. See you next time and bye-bye.
Bye.
Bye.
See you
Thank you
next
very much.
time.
Terima
Yes.
kasih Pak Aziz, terima kasih
Thank
semuanya.
you, Mr. Prastyo. Thank you, Mrs. Penny.
Thank you, everybody.
Thank you, everybody.
Thank you so much.